Okay, so I want to start with an overview of the unit and the software, how we set up references, how we set up that string list. Then I'll go into some of the functions of the unit besides the internal resistance and specific gravity measurements. We'll cover specific gravity readings and pairing the 2003 to 6500 and how to file that data away in a string. I'll show you the live monitoring feature of the unit, and then we'll talk about the extended leads that you asked for, kind of the design criteria, our progress through that development to get to the point that we've got the prototypes ready to go, and where we're at with those. The SBS 6500 unit, when we brought this in the house and we started developing it for use in the market, I came out of the UPS service field myself. So as a previous field engineer, I wanted to put features in the unit that would be helpful to those who do a lot of battery maintenance. And one of the problems that existed in the market was there are a lot of testers out there, but after you took 5 sets of readings or 10 sets of readings, you'd have to download all that data, then you'd have to reprogram all your reference values and set up new locations to take measurements at, and it got tedious, and every time you wanted to go take a set of readings, you had to do something with the previous data before you could take a new set of readings. So when we designed the unit, the firmware, the software, we put into place a large reference library with 200 slots so we can store 200 different battery reference values. So our reference database can be published with 200 different battery models, different battery manufacturers, and I only have to establish a reference value once for a particular type of battery. So DataSafe HX12400, I make one entry in my reference database for that battery, and then I can use that same reference on every string of HX400 batteries that I measure in the future. So once I set up an entry in that reference database, it stays in there. And then I can populate that list out all the way to 200 different battery models. So I don't have to repeat the same battery over and over again, filling up space. I only have to have one reference for each particular battery type and manufacturer. To set up reference values, we're just going to go in and we're going to type in, let's see, today's demo is an S-12400 made by SBS, lead acid, valve regulated battery, 12-volt block. My low voltage limit is typically my minimum acceptable float voltage out of the manufacturer's documentation. So I'm going to set this one at 13.4 just for the purpose of the demo today. The cells per jar block in the reference database. This is always going to be a 1 with the following exception. If I have a 6-volt flooded block that I'm going to be measuring 6 volts of voltage, I'm going to be measuring the resistance of that entire 6-volt block, but I'm going to import 3 specific gravity readings for that overall block voltage and internal resistance. Then I would set that number of cells per jar to 3. Otherwise, if I'm doing individual cells, if I'm doing valve regulated batteries, that number is always going to be a 1. Amp hour capacity. This is actually 400 watts, but I'm going to put it in as a 58 amp hour battery. And reference impedance. Right now, I don't know what the reference impedance value of this is off the top of my head. So I can check this unknown checkbox, and it will allow me to use this reference to take readings. And then once I find out that reference value, either through the average of my readings on the batteries or from a published value from the manufacturer, I can put that correct impedance value in there, and it's going to go back and update all the pass, warning, or fail statuses. So to start the demo, let's add this battery as an unknown. Once you click the add button, it's going to set aside space in the unit for that information. And then when we go into our string list and we add a string for the demo today, we're going to call this demo 1122. And then I pick my battery reference from all the values that are listed in that reference database. So there's my S12400. Yes.
Yeah, no, sorry to interrupt. Hey, this is John Pelez. Just got a quick question on going back. I meant to catch you earlier, but I hit the wrong button. I hung myself up. But on the reference criteria on the previous screen, is there any way of getting watts instead of amperes? UPS application batteries, a lot of battery manufacturers don't supply amperes.
Right.
That's that makes it difficult to get.
Right. So in your particular application, doing UPS service with these, you could enter the watts per cell as that amp hour. All that, it doesn't do anything with the calculations of the software. It just helps you identify that battery when you pick the reference value.
Okay, it's no way to, and the only reason I'm saying that, people in the field, and you guys that are on the call can chime in if you think I'm wrong, but they're going to see that and they're going to be hunting down amperes because that's what the label says.
Okay, so
now,
what
I guess we can make sure.
What I can do is in the firmware for the units that you guys will receive, I can make a firmware change to change that wording of that so that it would say watts versus amp hours. But then when you get into your guys that are going out and measuring flooded cells,
that's still watts per cell too.
Yeah, 40x11, is that rated in watts per cell or is that rated in amp hours?
Watts.
Okay, so for your guys' particular application in UPS service only, it may be better to have that in watts, and we can do that on the firmware side. I can't do that in-house, but I can send a firmware update out for the units that you have, and it's just a software update to add that firmware change.
Yeah, and I was glad to hear you say that it really doesn't matter. It could be watts or amperes. So it may be as simple as we just put instructions out and saying, hey, you can use the ampere value or the watts per cell value, either one, whichever is available at the time, because we don't do just UPS applications.
Now that we've assigned that reference to that string, I can set up the unit to take measurements at that particular location or that particular piece of equipment. So anything that we do in the left-hand side of the software here is exactly the same as if we press that button on the physical unit itself. So if we press data or we press SG upload or we go into the ohms measurement mode, in the software, it's the exact same thing as if I was pressing the buttons on the unit. I explain this, so as I'm manipulating the unit to show you how it works, you guys realize I'm pressing the buttons on the unit instead of pressing them on the software. In order to take new readings, I'm going to go into data. I'm going to use that rotary key in the center. I'm going to scroll over to record new readings. So I rotate it to the right. I press the F4 key. Here's my list of all of my different battery strings or battery systems. I'm going to scroll down that list with that rotary key or with that arrow key to get to this demo that I set up. So there's my demo for today, and as soon as I select the right battery string location, then I'm going to press the F1 select key to start taking readings. The screen initially goes into the memory block. So if I have any previous tests on that battery system, all of those tests are going to show up in these columns by the date that those measurements were taken. So when we did the memory of the 6500, we did it so it's capable of recording 250 cells within any battery string, and then I can record 100 historical data points or maintenance values for each one of those cells or batteries across the life of that battery system. So because this is a brand new string, I'm starting out at test number 1, cell number 1, and I just simply press that F1 key to start taking my measurements. So I take the probes over to the battery. The unit is polarity sensitive, so I do have to match positive and negative. As soon as I connect the probes to the battery, it's going to measure voltage, negative post temperature, and the internal resistance value or impedance value of that particular battery. So you'll notice at this time I did not get a pass, warning, or fail status because here in the upper left or right hand corner, I don't have those warning and failure levels in there. I initially set this up as an unknown reference value. So now that I've got a measurement here, I can actually go back into that reference database entry. I know my range is going to be somewhere around 13.5, so just for purposes of demonstration, I'm going to set this at 8 to start with. That's going to give me 10 and 12 as my 130 and 150% values. And then when I hit save, it's going to update that result.
So if I come up to a site and I actually do not do any of the setups that you had just shown us, right, can I get away with doing a 12-volt battery and forget the mins and maxes and the alarms, and then just transfer all that information into our field DB with our own mins and maxes? Will I be able to skip this setup?
Yes, you will. So you can take the unit as it is. All I have to do is have a string name and a generic reference. So we set up generic references of 12-volt VRLA, 6-volt VRLA, 8-volt VRLA, 16-volt VRLA, 2-volt flooded, 6-volt flooded, 8-volt flooded. That allows you to take those readings, and then that data would come out as Commons Limited data, go into PowerDB, and then your references in your PowerDB would flag all of your warnings and alarms.
Thank you. That answers my question.
Yeah, so when I'm in the report interface, I can do PDF, Excel, or Word as those 3 report options. So when I go into that string list, I'll actually see all of my pass, warning, or fail status for that particular cell. So what I was trying to point out was that pass, warning, or fail, those IR values, that low voltage warning, is actually what triggers that pass, warning, or fail result in the report on our side. And that's how we get this pass, warning, or fail status. So
one more question.
With that reference value in there now that cell comes up as a fail. Yeah, go ahead with your question.
If the meter does the temperature, does the specific gravity SBS tool also do the temperature?
No, so right now, the way the firmware is set up, we're using the recorded negative post temperature in the report for the 6500 unit, We are only importing the temperature corrected specific gravity.
Okay, thank you.
Because we're using the unit on both valve regulated and flooded batteries, we felt that the way to go was with the battery post temperature, because you weren't going to have a specific gravity and a specific gravity temperature for all the products that you're using the unit on. In our report feature, we simply select the string or the battery location. And then if you have multiple tests on that string, so as I go back to that same UPS or that same substation over and over and over again, test 1 through 20, I can go through and print any report of any history I want for that battery string. So I'd select the test number. I could put in a technician's name, a system location, any recommendations or notes, and then simply click make a report. It's going to take all that data for that location, and it's going to generate a battery condition report. So here's my battery condition report. It indicates pass, warning, or fails. At that same time, it's going to give me a summary of my results as well as all of my averages. So it's going to average the impedance values, the voltage readings, and the specific gravity readings. Graphically displays those in color-coded charts as to pass, warning, or fail indication. And then there's that specific gravity data merged into that file. From here, it goes to Excel. One of the features of the unit that we did was a feature called live monitoring. So with the unit in the ohms measurement mode, I can connect the 6500 unit to the battery, and it's going to begin trending data in real time. So I've got a battery here and a charger here connected. So what this allows me to do is it allows me to go in and it allows me to start measuring these values in real time and trending that data. So then I can screen capture or I can save that data, the recorded readings as long as the values, and then compare those to good known batteries to determine just how critical that pass, warning, or fail is. So if you're just collecting data, you're going to go into data, you're going to go into record new readings. I'm going to select a location if I've already taken measurements there previously. If it's a brand new site, I can scroll down. Here's a brand new string, so I just put new string on the unit without having to have the software. I can use the keypad. I can type in U.S. Bank Building. So I edit that, I use the keypad, I type in U.S. Bank, I hit OK. And then I just start taking readings. There's my new string, and I just go to my battery system and I start taking readings. Once I've got that data recorded, then I simply hit report, select that location, make a report, yeah, so there is a built-in zero adjust feature. So if you take the pins or the clamps or the probes and you put those both on the same source and you hit that zero adjust, it will go through and it'll zero out all of the resistance of the lead set itself. So where this is going to come in and be important is if I shift from the small pin probes into the larger extended leads, those two lead sets are going to have different resistances, and that zero adjust would cancel out the resistances of the leads.